What's up, guys? Dylan here, and welcome to day 15 of Advent of Code 2020 in Python. If you find this video helpful, like always, please feel free to leave a like, drop any questions, comments, feedback, anything in the comments below, and let's get on with day 15. So, day 15, Rambunctious Recitation. So, we are playing a memory game, and they're excited to explain the rules. We're going to start by taking turns reading numbers from a list of starting numbers, which is our input, and most recently spoken number. So the first time the number has been spoken, the current player says 0. And how many, otherwise, if the number has been spoken before, the current player announces how many turns apart the number is from when it was previously spoken. So if we say 0, 3, 6, so 0, then 3, then 6 for our starting numbers, and now 6. 6 hasn't been spoken before, so the fourth number is 0. Then 0 has been said before, so 4 minus 0, index 0, is 3. And then 3 has been spoken for, 3 is an index 1 and an index 5, so then 3. And now we have two 3s in a row, so the difference between them is 1. 1 hasn't been spoken before, add 0. Okay. And the elves want to know what is the 2020th number of the game. So let's go ahead and get into this. Well, we've got to grab our puzzle input first. Let's not get ahead of ourselves. So Control C here, paste that in. Now we got to parse out these integers somehow into, I'm thinking into a list. So let's say with open file, of course we have to tell it which file, input15.txt as a file. Then we can say data is equal to file.read lines. I don't know if that's necessary because it's only one line, but I guess we'll see data, and let's turn that into a string. So data 0 dot split by the comma, and then I think that should work, and then data will be equal to int num for num in data. So if we go ahead and print out data, let's see what we have here. That should be data 0, shouldn't it? Okay, so there's our lists. So now let's go ahead and write a function called play memory game. And I'm thinking we gotta keep track of, I'm thinking we can keep track of the most recent index in, because we're going to be adding on to this, and eventually this will be 20,000 long, or not 20,000, 2020 long, and so technically we could loop back, just loop back through it to find the most recent index, but I don't know how long that's going to take, because that could potentially be a loop of like 20 or 2,000. So I think the most efficient way to do it here, would be to keep a dictionary called memory, and then we can say, well, we gotta load our initial numbers into memory. So for I in range length of data, then num will be equal to data I, and mem will use the numbers as the key value, and then their index as the data value, though because we want to be able to check if num is in memory, we will want to later on, is equal to data I. Nope, just kidding, that'll be just I. And so now we could say for I in range length. Well, we want to start on the last index of the list and go to 2019, because 0 to 2019 is 2020 numbers. Computer science counting right there. And once again, we'll say num is equal to data I. And then we can say if num not in memory. So this is the first time that we're seeing the number. Then data.append a 0, because we haven't seen it before. And then we can say, well, this is going to create an issue the first time, because if we load all of the numbers into memory, then of course well, we don't want to check the first instance. So like when we say 6, of course 6 is in data right now, but we only want to check the 0 and the 3. So if we say range length, so we'll add all the numbers into all the starting numbers into memory except for the last one. And then we can say memory of num is equal to I. Else, so here's the case where we said the number last turn and it had already been said before. So it's technically been said twice now. So the number is in memory, so we'll just say j is equal to memory of num. And we can say new num is equal to the index that we're on and j, so the difference that our current place and the last time it was said is. And so then we can say data.append, add the new number that was just said to the end of the list. And now we can update and say that if then mem of the old num is equal to I. Yes, so then we update the last time that we saw it. And then at the very end, we can return the 2020th number, which will be in position 2019, or the second to last position in data. So now if we print play memory game, let's see what we get. 614. All right, there's part 1. So part 2, impressed, the elves issue you a challenge. Determine the 30-something number to be spoken. For example, given the same starting numbers above, blah, 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 blah. Okay, what will be... Okay, so if you remember when I was explaining earlier about how, like, we could loop back through to find the most recent instance of a number, but in the case that that number, like, it could be, like, we could be at index, like, 100 or, you know, like 1,000, and the last time we saw a number could be at index 1. We're doing a lot of looping, so that's why I put things into the dictionary, and I think that's going to pay off, because instead of looping through the whole thing, if you know about like big O notation, accessing a dictionary is just O of 1, whereas looping through the list is O of n each time. So it's much, much more efficient just to access numbers out of a list. So now I'm kind of glad we did that. Now the issue is it might still take a long time, but I don't know. I can't think of a way to make this more efficient here. So we'll say print play memory game again, and this time we're going to give it an argument. We'll just say our size, and so then we'll say size -1 for this loop here, And then that'll still give the second to last instance. So, okay, so let's say 2020, and then what the heck is this big number? 3 with, I think that's 7 zeros, but to be safe, we're just gonna paste it in here. So if we go ahead and run that, okay, oh, this is gonna take a while. Alrighty, and we've gotten an answer. That took about maybe 10 or 15 seconds. So my guess is that it could be more efficient, but I guess this solution does work. And what even did we get? 1065. Okay, and there's our answer. So once again, that solution probably could be a little more efficient, but for the purposes of this problem and the length that we were given, it worked fine. If you find this video helpful, please leave a like down below, subscribe for more days of Advent of Code, and I will see you tomorrow for day 16.